All right. Suppose that 40% of cars in Bangor are manufactured in the United States, 30% in Japan, and 10% in Germany, and 20% in other countries. If cars are selected at random, find the probability that a car is not U.S. made. So, if 60%. We see not, then yes, we want to subtract off all the things that are outside of the U.S. So, basically we can do 1 minus the probability of the U.S., which would be 1 minus 0.4, which is 0.6. And remember, probabilities are decimals, even though it's tempting to write them as percents because they gave us information in percent.
Oh, so we shouldn't write information in percents?
No.
Okay.
It should always be a decimal.
The next one is 0.4.
How did you get that?
I added 10, or I added, wait, where'd it go? 30% in Japan and the 10% in Germany, and I subtracted that from 100.
You subtracted it from 100 and you got 40?
Oh no, I just added.
Yep, we added them together, so that gives us 0.4. How about you see 2 in a row from Japan?
I have no idea.
So what's the probability that the first one's from Japan?
30.
Okay, so 0.3. And then the next car that we see is from Japan. What's the probability of that?
0.3.
0.3. So we multiply them, which will give us 0.09.
Wait, that look makes a lot of sense.
None of the 3 cars came from Germany.
So we had everything that's not Germany? And then
Yep.
Okay.
So basically, we're doing, it's 1 minus the probability that it came from Germany, and we have 3 cars in a row that are that. So we have 1 minus the probability of Germany, which would give us what? 0.9. And then 3 cars in a row, basically, that are not Germany. We would have 0.9 times 0.9 times 0.9, or we can say 0.9 cubed, either way. And this comes out to be 0.729. At least one of the 3 cars is U.S. made.
Will it just be 0.4?
When I see this, what do I think of?
Oh, I don't know.
What is that phrase supposed to remind me to do? Or make me think that maybe I should do?
Like, also count the ones that aren't, like, everything except 0.
It's a word that starts with a C.
Count.
It's what we did in Part A. It has a special name.
Subtract?
Virginia, you're very beautiful today.
Compliment.
Yes.
Thank you.
Compliment. So, this would be 1 minus the probability that none are U.S. made. So basically, not U.S. made is going to be 0.6. There's 3 cars, though, so it's going to be 0.6 cubed, and then I'm going to take that and subtract that from 1. So this is going to be 1 minus 0.6 cubed. So we would cube the 0.6 and then do 1 minus that, and that's going to end up giving us, make sure I have this right, 0.6 cubed 1 minus 0.784. The first Japanese is the fourth one you choose.
What?
The first Japanese is the first one you choose. So basically, I have 3 that are not Japanese, followed by 1 that is.
So multiply the probability that you get.
So basically,
0.7 times 0.7.
I know that the fourth one is Japanese, which is 0.3. So what would go in these other ones? I think you're just saying it, but
0.7.
Okay.
yeah, everything. So basically, not Japanese for the first 3, which would be 0.7. So these were all not Japanese. And then this one was Japanese. What? Oh. Hold on. Times 0.3, not -3. There we go. 0.1029. All right. According to Pew Research, the contact rate, probability of contacting, supposed to say contacting, a selected household was 69% in 1997. That's the year I was born. And 76% in 2003. However, the cooperation rate, or the probability of someone at the contacted household agreeing to be interviewed, was 58% in 1997 and dropped to 38% in 2003. What is the probability in 2003 of obtaining an interview with the next household on the sample list? To obtain an interview, an interviewer must both contact the household and then get an agreement for an interview. Okay, so this one's going to be 1 because there's a lot happening. That's better to make a diagram. So I'm going to do the 2 little branches like we did on that one the other day. The first one is going to be contact. The other one is no contact. Now, if there's no contact, there's no chance for an interview, right? So I don't need to add anything else on that branch, unlike what we did the other day. But if there's contact, we have to see if they will agree to an interview or not. So no interview, I'm just going to do INT, or interview. All right, and we are specifically looking at 2003. So we were told that the contact rate in 2003 was 76%. So 0.76 would be that number. I should have written that in before I kept going with the little chart. No contact, that it would have been 24% or 0.24. And then interview or no interview. In 2003, there was a 38% that agreed to an interview, so 0.38 goes here. And then no interview would be what's left, so what is that, 62? 0.62. Now, could I have done this without having to draw the diagram? Yes, but I think it's good to see the diagram because there are going to be some that you're going to need the diagram for it to make more sense for you to think about. So they have to contact the house and then get an agreement for the interview. So that's going to be 0.76. So that's the first part, times the agreement for the interview is 0.38. So 0.76 times 0.38 gives us 0.2888. And a lot of things they're going to round till either like the 100th or the 1000th place, but since this one was just, that is unrounded, I'm just leaving it. If it specifies, then you should obviously do whatever it says, but I don't care as far as anything else. All right, so then, was it more likely to obtain an interview from a randomly selected household in 1997 or in 2003? So essentially, I'm going to do the exact same thing without drawing the little chart for 1997 because I now at least know what the setup is supposed to look like to know what that is. So this is the one for 2003. So then for 1997, contact was 69%, so 0.69. Times getting an interview was 58%, so 0.58. We multiply those. Which gives us 0.4002. So which one's more likely?
2003. I mean, sorry, 1997.
1997. All right. Choose an American farm at random and measure its size in acres. Here are the probabilities that the farm chosen falls in several category. Sure. Let A be the probability that a farm is less than 50 acres in size, and let B be the event that it is 500 acres or more. Find the probability of A and probability of B. So A is less than 50 acres in size. So probability of A. Now, these are mutually exclusive events. It can't be both at the same time. I can't spell either, apparently. Mutually exclusive events. So we add. So less than 50 would imply that it is in this less than 10 range or the 10 to 49. So I add these two numbers together. So 0.09 plus 0.2 is 0.29. And B is 500 acres or more. So that's these last three blocks down here. So I'm going to add those things together. So the probability of B is 0.09 plus 0.05 plus 0.04, which is that 0.18. Whoa, that was a weird 8. All right, so let's see if y'all can do this. Describe a complement in words. Let's do that part first. What would that mean if I told you to tell me what the complement of A is? Like in the context of this problem specifically. So we know that A is farms that are 50 acres, or less than 50 acres. Yeah. So 50 acres or more. So A complement would be farms that are 50 acres or more in size. And then they want us to actually find that by the complement rule. So the probability of A complement, how would you tell me to write that?
1 minus 0.29.
Yep, so 1 minus, I'm going to do it this way first. 1 minus probability of A, which would be 1 minus 0.29, which would be 0.71. And I'm just writing that out so that y'all can see it. You would be totally fine to just say 1 minus 0.29 if this was a quiz or test. So then in words, describe what A or B means. like the probability of A or B, like in the context of this problem. Like what farms would that be including?
Farms that are less than 50 acres and more than 500.
Yep. So this would be, so it's just A or B means farms that are less than 50 acres or 500 plus acres. So mathematically, when we do this, or is the addition, like this is an addition rule with or, they are mutually exclusive, so we don't have to like, there's no overlap is what that means. It's not possible for a farm to be less than 50 acres and also more than 500 acres. So the probability of A or B, we could also write as the probability of A union B, just as a reminder, is the probability of A plus the probability of B. Probability of A is 0.29 plus B is 0.18, which is 0.47.
Got my phone out.
Thought you were going to tell me I made a mistake, and I was about to be like, are you kidding me? Like, you're not getting a cookie point for that.
Put it on last year's grade somehow.
All right. Choose an American at random. Define two events. A is that the person has a cholesterol level of 240 milligrams per deciliter of blood or above, which is high cholesterol. Or B is the person has a cholesterol level of 200 to 239 milligrams per deciliter, which is borderline high cholesterol. According to the American Heart Association, the probability of A is 0.16 and the probability of B is 0.29. So basically, a lot more people are borderline than are actually high. So explain why events A and B are mutually exclusive. So this is just like in words in the context of this problem. Why are these things mutually exclusive?
Because they have like different levels of cholesterol.
Yeah. You can't be borderline high and high. Like it doesn't work that way. So a person either has high or borderline high cholesterol. We can't be both at the same time. Now, you can go from being borderline high to being high, but you can't be at the same time. All right, this is a little bit of a weird way to word this question, but say in plain language what the event A or B is and what is the probability of A or B. So essentially just in words explain what A or B is.
So A is like high cholesterol people?
Yeah.
Okay.
So basically all you need to say is A or B is someone with borderline high or high cholesterol.
Oh.
Like that's all it's asking for. That's why I was like, it's kind of a weird way to word the question.
Plain language.
Yeah. So A or B is someone with borderline high or high cholesterol. And then what is the probability of A or B? So if you actually were going to find that mathematically, how would you do that?
You would add 0.16 and 0.29.
Yep, 0.16 plus 0.29 which gives us 0.45. So then, if C is the event that a person chosen has normal cholesterol, which is below 200 milligrams per deciliter, what is P of C?
Would it just be 55? Because you're just doing 1 minus. Okay.
Yep, exactly. So I'm going to write it out, but yes. So P of C is 1 minus the probability of A or B, which is 1 minus 0.45. So the probability of C is equal to 0.55. So, yes. Some of it's kind of like common sense, but like just trying to write down the formulas for actually how we get there in case you go back and you're like, how did I get this number?
Yeah.
All right, 10. You have two sets. Set 1 is A, B, C, D, E, and set 2 is K, L, M, N, O, P. If you pick one number from each set, or well, letter, what is the probability that you pick at least one vowel? So let's do this. How many vowels are in this first one? 2. So there's 1, there's 2. How about this one? 1. Okay. So, at least one, at least says I should be thinking what? Complement. So, at least one vowel. I would say let's do 1 minus the probability of no vowels, because anything more than none meets this criteria. So 1 minus the probability of no vowels. So this is going to be 1 minus, in here, I'm going to be multiplying the numbers. So no vowels. So that means I need to know basically how many consonants are in each one. But I'm going to have to write them as fractions and get to a decimal number. So there are 3 consonants out of 5 total. So 3 out of 5 times. There are 5 consonants in here out of 6 total. So 5 over 6. This one actually works out kind of nicely because of the way things are going to cancel. Because 5 and 5 cancels here. 3 and 6, that basically just makes 1/2. So 1 minus 0.5. So is 0.5. So essentially, it's like a 50-50 shot that you're going to pick at least one vowel, more or less. So we could say then there's a 50% chance of picking at least one vowel. But the probability is 0.5. But that's kind of like how we would interpret it with what I wrote on the side there. All right. We had one kind of like this the other day. It was a little different. So, a new clothing store advertises that during its grand opening, every customer that enters the store can throw a bouncy rubber cube onto a table that has squares labeled with discount amounts. The table is divided into 10 regions. 5 regions award a 10% off discount, 2 regions with 20%, 2 regions with 30%, and the remaining region awards a 50% discount. What is the probability that a customer gets more than a 20% discount? Okay, so just for our reference before we go into that, I'm going to list out the probabilities of each thing as a fraction before we keep going. So 10% is there are 5 out of, they said there's 10 regions, so 5 out of 10. 20% is a 2 out of 10. 30% is 2 out of 10. and 50% is 1 out of 10. And it's important to remember, the reason I did like the lines between them is I want to make sure that I'm not thinking that, 5 out of 10 is 10%, right? So, I mean, it just, the way you write things can make it a little bit weird sometimes. So part A, there's 2 different ways I can work this problem. I'm going to work it both ways just so that we can see it, because it's pretty much the same amount of work either way we do this. So the probability that a customer gets more than 20%. So what discount does that imply that they can get out of the options?
50 or 30.
Yep. So I can either do the probability of 30 or 50, which would be 2 out of 10 plus 1 out of 10, which would give me a 3 out of 10 or 0.3. The other way I can do this is with the complement rule, and I could do this as 1 minus the probability of getting 10 or 20. This is why I said it's pretty much the same amount of work either way we look at this one, because there's still 2 things being added here, just like there were 2 things here. It actually probably is easier to do it the way that I have written in red versus the way we're about to do, just by like a teeny tiny little bit, but either way it would work. So 1 minus that would be 1 minus 5 over 10, which I would need to do this, plus 2 out of 10, or 1 minus 7 over 10 would be 3 out of 10, or 0.3. So either way, you're going to get to the same answer. More so showing you both ways, because if there were a lot more numbers involved, it might be easier to do what's in blue versus doing what's in red, depending on what's going on. All right, what's the probability that a customer gets less than a 20% discount?
Yeah.
Can I have your attention, please? This is the final call for any Operation Christmas shoeboxes. Again, this is the final call for any Operation Christmas shoeboxes. Please turn them in to the main office. Thank you.
So, what discount can they get if they get less than 20%?
The 10 move.
They only get 10, which is 5 out of 10. So this is the probability of 10% basically, which is 5 out of 10 or 0.5. What is the probability that the first 2 customers both get a 50% discount? I think I've set this one up. Well, remember, it's out of 10.
Oh, so like 1 over 10 times 1 over 10?
Yep. Which ends up being 1 over 100, which we know, I mean, you can also put it in your calculator, is 0.01. So basically, there is a 1% chance that the first 2 customers both get a 50% discount.
That's like even horrible odds, actually. That's not like...
Well, 2 people in a row. So basically, if you go in with your family,
No, it's split up.
What if you go with your family and like you get a 50% discount, another person in your family gets a 50% discount, and then they get a discount to you?
100% discount.
yeah, I don't
It
think it
never
works like
works like
that.
that, though. It's like 50%, and then they take 50% off the 50%, and then
No,
it's
that would
like...
be 75.
Yeah, 75%. That's what they do.
Well, that's what, so, like, sort of off topic, but kind of the same thing. At Busch Gardens, we pay for, like, the maximum pass that you can have, because, like, we've gone to, like, all the different Busch parks,
Yeah.
like, Florida and everything.
I didn't know that.
So, we have, like, the maximum pass. Well, our pass gets, like, a 40 to 50% discount on just, like, souvenir type stuff there. And then they often will give you like Bush Bucks, which is like just like a $10 gift certificate essentially that you can buy like whatever. Like it makes our pass worth it. Like it really pays for itself. So it's, it's whatever. Well, it's funny because sometimes what they do is they take the $10 off, then they cut it in half. Sometimes they cut it in half, then take the $10 off. Like, it's whatever their system does, like how it processes it or whatever. So I usually will like hold my little $10 thing till the end, and I make them like scan my passwords, and I'm like, oh, I have this, by the way. I'm like, the system may still flip it sometimes, which is kind of funny. And then there was another thing that we got one time that it was like I was getting something for my nieces and nephews because we had the $10 reward. I have my pass, and then Stuffies were an extra 20% off, like bonus or whatever. And sometimes you can't stack all those discounts, but in this case it worked. So the item was like $32. And I was like, okay, so is it going to take the 20% or my 50% first? Because that's going to make a difference in like your final cost or whatever. And then I also had like the $10 thing on top of that. So I was like, okay, so I was like, it's 50% off. And then I was like, okay, 20% of that. But then I was like, well, actually, it'd probably be better if they took 20% first, which is what they do. So it like took the 20% off, then it took the 50, and then I had the $10, and I think I ended up paying like $4. I was like, score. Like, but it was just, you never know like what order they're gonna take this stuff in, which like is unrelated to
That's
this,
funny 'cause
obviously,
you'd
but
think
it's
it would
just comical.
You would think like the system would like make it in a certain order no matter what. That's kind of weird.
Yeah, because like you would think like, okay, well, because somebody was like, well, if you're getting like a 50% discount and a 20% discount, that's getting 70% off. I'm like, but it doesn't work that way. I'm like, it's going to take the 20% off the item, because those items were made so that as soon as they rung up, they were ringing up at the 20% off, which is how I knew what it was doing. But it's just like so weird how like you can go one day and it rings up this way, and then the next week you can go and get like the exact same thing and it rings up a different way.
Yeah. That's like how it is with Bath and Body Works too. Like when they send you all those little coupons, and like sometimes we have my mom and I do like separate orders, because like we'll have like a free $16.95 thing, and it'll take it off, so it's like $8. So she's like, I'm just gonna wait and do it separately.
Yeah.
Because it depends on what.
It takes it off like the least item, and it's like,
Yeah.
but that's not, but they can't control that. That's just how the system registers it. I'm like,
Yeah.
yeah, it's so annoying. I was like, whatever. But anyways, unrelated side note, but back to our discount situation here. What is the probability that none of the first 3 customers get more than a 30% discount?
That none of them do? That'd be.
So like 30 and below, and then times 3.
Yes. It might be easier to think of it as a compliment, though.
Okay.
Because if I do 30 and below, I have to add up the 10%, the 20%, and the 30%. Add all of those together, then cube it, because that would be 3 times that. The other way I can do it is 1 minus the probability of getting a 50%, which is 0.1, and then cube that number. So either way, we're going to get the same answer, but just to save you some extra numbers, it might be a little bit easier to do it this way. So I would do basically 1 minus 0.1 and cube that, so 0.9 cubed, which ends up being 0.729 when that's all said and done. All right, this next one's kind of getting a little intro into kind of the rest of the unit here. But what is the probability that the first customer to win a 30% discount is the 6th customer that enters the store? So what does that mean the first 5 customers had to get?
No discount?
50,
Oh, wait.
10, or 20.
Yep. So essentially, we're going to have 1 minus the probability of getting a 30% raised to the 5th. Then multiply that by the probability of getting a 30. So it's the probability of 1 minus the probability of 30 raised to the 5th plus, times, I don't know why I said plus, times, do it this way, the probability of getting a 30 after that. So 1 minus this probability would be 0.8 raised to the 5th. And then the probability of 30 is 0.2. So I just added everything up here or did 1 minus that probability. And this comes out to be 0.0655. What is the probability that there is at least one customer to win a 50% discount among the first 5 customers that enter the store? Yep, compliment roll because we have at least one. So I would say that we do 1 minus the probability that none of the 5 win a 50%. So this is going to be 1 minus the 0.9 raised to the 5th. Notice this one's a little different because we have 5 people in a row that are not getting a 50%. It's 1 minus that versus the other ones, the way that they were written. The probability that none of the first 3 get more than a 30%, it's the whole thing when we were doing the complement. It's different on what we're doing the complement of. Are we tracking? So basically, I would have in this one, the first 5 people, none of them get a 50% is what I'm doing.
Okay.
So that is 0.9 raised to the 5th. Is that they get something other than that. I need 1 minus that to get my answer. The other one up here was the probability that none of the first 3 customers get more than a 30% discount. So we did 1 minus the probability that they did get more than that, and then we cubed that number.
Okay.
So it was dependent on, were we taking the complement of the first like each person individually, or were we doing it of like the whole thing,
Okay.
essentially?
So the 5 comes from like the 5 customers?
Yeah, because there's
Okay.
first 5 customers to enter the store.
Okay.
So this one ends up being 0.4095. Basically, there's like almost 41% chance that the first 5 customers are not going to get a 50% discount. So, as you enter the store, you watch 4 people in front of you all win 50% discounts. The store manager tells you how lucky you are to be throwing a cube while it's on a hot streak. But a friend says you're unlucky because the streak can't continue. Comment on these statements.
I never talked about this.
Well, the hot streak isn't like real, right? Like that's just like,
Policy. Oh.
yeah. So it's like,
Law of averages. It's a
Fallacy.
policy.
Fallacy.
Oh, what? Oh.
Each throw is what of the other? Independent. Every throw is independent. So the probability of you getting a 50% is the same for every single person. Now, the probability of that many people in a row getting it is obviously going to be very different. But I have an equal chance as each of you of getting a 50% when we go up to throw. Now, if I'm a really good shot, then maybe I have a better chance. But that's irrelevant to the generic problem. If we all just randomly closed our eyes and tossed it, we have the same chance of getting it, right? So each throw is independent. So prior rolls don't affect the outcome of future rolls. The probability is 10%, or well, let me say, is 0.1 for every roll for a chance of getting a 50% discount. So both statements are false. But yes, the one that says that the streak can't continue or whatever, or even that it's a hot streak, that is kind of like law of like averages, saying like, oh, well, you know, it's due to miss because it's hit this many times or whatever. So, do you want me to give you the problems now, or do you just want to get them tomorrow? Okay. You'll have all of class tomorrow to work on them, and I don't think they're that long. I mean, it shouldn't be anything crazy.